Assalamualaikum and hi to the viewer. My name is Muhammad Nabil Rosman. So this is my other group mate, which is the first one is Shazwan Hakimi bin Samsul, and the second one is Nur Hanim binti Amar Rashid. So we are from 3BI session 1/1, and this video we would like to present about our assignment for power system and protections. So for this assignment, we choose to present and explain about the national electricity blackout of the Turkey in 2015. So first of all, I would like to explain about the incident data. And first thing we need to know that in Turkey, the highest electricity consumption occurs in the summer period, and the lowest electricity consumption occurs in the spring period. However, some problems have occurred at the transmission lines during the consumption of electricity due to the insufficient infrastructure. So the unbalanced voltage and frequency variation are at the top of this problem. And on 31st March 2015, a national blackout occurred in Turkey. It coincided with the summer period and the national electricity network collapsed in 3 seconds. So before we explain and discuss about these incidents, there are some information that need to be known, which I will present after this slide. So we need to know there are 11 important transmission lines for supplying electricity service from the eastern to the western side of the Turkey. So their total rough length are higher than 265 km and operate at 400 kilovolt. So before the national blackout, the four most important of these transmission lines were held offline for both minor and major maintenance. The first transmission line is the Kayabasi Belglum, and the second and third transmission lines are the north and south side of Golbasi Kayseri, respectively. And the fourth transmission line is in the Oymapina Emirate. So this transmission line are shown in the figure 1. So this is we can see that this is the four most important transmission line in the Turkey. And where is it? Where each of the transmission lines located. So after that, we move to the occurrence of the national blackout. So before the national blackout, the consumption of the west side of Turkey was 22.87 gigawatt. So in total, 2.19% and 20.5% of this power was provided by Bulgaria and the eastern side of Turkey, respectively. So the important four transmission lines, given that I explained before this previously, were held offline for the minor and major maintenance. Sorry. So therefore, electricity service was weakened from the eastern to the western side of Turkey. So before the national blackout, the frequency variation start due to the inability to meet the power demand of the west side. So the first frequency variation occurred in the Osmanka Konsulu transmission line, and it was recorded as 9360942 on 31st March 2015. So the second frequency variation occurred in the Atatürk Yasin Hilsa North transmission line, and it was recorded as 936 1088. After the consecutive frequency variation given in the figure 2, the distant protection relay tripped due to the factual sequence events. So the parallel transmission lines given in the figure 1 in the previous slide will consecutively separate one after another from the national grid. So hence the synchronization was lost within seconds, and the national blackout occurred at 9:36, 12, and 53. So this figure shows the frequency variation of the national electrical network before the national blackout. So we can see that this is where the starting point of the frequency shifting, and before we go to the frequency variations. This is the first frequency variation, second one until the 11th frequency variation. So after all these frequency variations, the synchronization was lost with the voltage, and then the national blackout occur at this starting point. So that's all from me. So my friends will continue the presentation.
So the chronology of protection evolved. Firstly, the west side of Turkey consumed 22.87 gigawatt of electricity, but four important transmission lines were offline for maintenance, which weakened the electricity service in the western side. 2.19% and 20.5% was provided by Bulgaria and the eastern side of Turkey, respectively. This mean it is mean that Bulgaria and the eastern side of Turkey provided a combined total of 22.69 of the electricity demand in the west side of Turkey. So the frequency variation began due to the inability to meet the power demand of the west side. It is mean the frequency of the electricity grid in the west side of Turkey began to fluctuate, which is a sign that the grid was not able to meet the demand for electricity. The first frequency variation occurred in the Osmanka to Kursunlu transmission line at 936.0942. This is the first time that frequency of the electricity grid in the west side of Turkey dropped below the safe level. The second frequency variation occurred in Antarctic to Yeşilhisar North transmission line at 936.1088. This is the second time that the frequency of the electricity grid in the west side of Turkey dropped below the safe level. The parallel transmission lines were consecutively separated from the national grid, which means that the four transmission lines that were offline for maintenance were disconnected from the national grid, which further weakened the grid, caused the frequency drop even lower. Synchronization was lost within seconds at the breakup occurred at 9:36:12:53, which means that the west side of Turkey lost its connection to the Europe Network Transmission System Operator, which is the European electricity grid, because this caused a blackout in the west of Turkey. Many power plants disabled themselves or switched to the island mode, even though regulations stated to stay in service for at least 10 minutes. This means that many power plants in the west side of Turkey stopped generating electricity or switched on a mode where they only generated electricity for their own needs. This further worsened the blackout. Next, the electricity service was interrupted from the east to west part of Turkey, where the blackout affected the entire country of Turkey from the east to the west. The NEN of Turkey lost its synchronization with the ENTSO-E system, which means that the national electricity grid of Turkey lost its connection to the ENTSO-E, which the European electricity grid. The internet connection of Turkey with Bulgaria and Greece was lost, which means that the electricity grid of Turkey lost its connection to the electricity grids of Bulgaria and Greece. Sorry. Then, okay. So after that, the restoration for this procedure was planned by TEIS, according to the 9 regional control center. That TEIS means Turkish Electricity Transmission Corporation. Then the RCC are responsible for controlling the electricity grid in the different parts of Turkey. After that, the recovery was started by obtaining electrical energy from Bulgaria, and then synchronizing it with the Northwest Anatolia RCC, which means that the restoration process began by importing electricity from Bulgaria and then connecting the Bulgarian grid to the Northwest Anatolia RCC. Each RCC has 3 or 4 restoration parts, and each path includes generator, where each RCC has a plan for how to restore electricity service in its area. The plan includes a list of generators that can be used to generate electricity and the path that the electricity can take to reach the consumer. The European part of Turkey started the restoration process by closing Hamitabat to Maritsa East 3BG Line 2 and supplying the electrical energy from the Hamitabat and Ambarli natural gas power plant, which means that European part of Turkey began the restoration process by closing one of the transmission line that connected from Turkey to Bulgaria, and then using the Hamitabat and Ambarli natural gas power plant to generate electricity. After 30 minutes from the start of the blackout, the central Euphrates system was used to power up the Thrace region of Turkey, which means that Europe was electricity grid of Central Europe was used to provide electricity to the Thrace region of Turkey. After starting up the several power plant in the Europe side of Turkey, some parts of the Asia side were energized. It is mean that after they starting up the several power plants in the European side of Turkey, some part of the Asian side of Turkey were able to generate electricity again. So the Black Sea side and the east side of Turkey was synchronized at 11:30.
Assalamualaikum warahmatullahi wabarakatuh. My name is Shazwan Hakimi bin Samsul and my matric number is B0820100073. And now I want to present the main cause of this incident. First is the relays and circuit breakers used for the protection of transmission line could not perform the fast electromechanical opening or closing maneuver. Next, the stability of some power plants was damaged due to lower load shedding than the required amount. Next, what is the impact of this incident? First is it caused transportation disruption such as the suspension of subway and tram service in Istanbul and Ankara and the cancellation of some flights at airports. Next, it also affected industrial production such as the halting of operation in some factories and refineries. Next, the blackout resulted in estimated economic loss of 700 million Turkish liras, is about 250 million US dollar at that time. Next, the blackout raised security concern as some government buildings and military facilities had to rely on backup generators. And last, the blackout also exposed to the vulnerability of Turkey's power system to external shock and internal failures.
So next is what's the lesson and the value that I get from this incident. So I understand that if the stability of a power system is changed from normal conditions to abnormal condition, such as overload, generator outage, transmission line tripping, the system dynamics such as frequency and voltage instability must be quickly controlled in time to prevent the cascading events that might lead to a blackout.
So the lesson that I got from the case study, which the role of diversifying energy source and increasing domestic production, especially renewable energy, to reduce the dependency on imported gas and oil, which are subject to price fluctuation and supply disruption. That's all.
And next, for me, the lesson from this incident is the need for enhancing situational awareness and emergency control measures in the system operator, such as real-time monitoring, load shedding, islanding, also frequency control, and restoration plans. Thank you.